In this question, we're asked to identify some points given a heating curve. So let's think about what a heating curve is. We have two axes. We have heat added, kilojoules per mole, and temperature in degrees Celsius. So down here at minus 10, we add some heat and the temperature increases as we add heat until we get to a point where it starts to flatten out. Well, down here on the heating curve, this is a solid as a state of matter. So as we add heat, the solid increases in temperature. Then we get a flat line. We're adding heat, but the temperature isn't changing. What is going on here? This substance is melting. So it melts as we add heat. The molecules become further apart, but heat is added, and there's no temperature change. Then we get to a point here where we start to add heat and the molecules start to get warmer again. The temperature rises again. Here we have a liquid. We then see another flat line, and it's very typical that this flat line is the longest of the all of the lines. The most heat is added to boil something, but we have boiling occurring, and it's longer than the melting line. So here we're going from a liquid to over here a solid, and this is boiling that is occurring here. Why does it take more energy to boil something than to melt it? Well, when you go from a solid to a liquid, there is a change in usually the distance between the molecules. They generally get further apart. However, when you go from a liquid to, this is a gas up here, when you go from a liquid to a gas and boiling has occurred, then you have really ripped the molecules apart. In this case, we consider them almost completely separated from each other. So here, in a liquid, they're relatively close, and in a gas, they're basically completely separated from each other. So after boiling has occurred, we've had a large shift in the distance between the molecules, and that takes even more energy. Now we can answer these questions, but I wanted to go over the general idea in case there were different questions on other examples that you might have. It asks, what is the boiling point of X? Well, boiling point is the temperature at which this flat line occurs. This would be the melting point, which would be 30.0 degrees C. In this case, the boiling point is 80.0 degrees C. Technically speaking, you do need that extra decimal place. The next question, it says, what phase, physical state of X would you expect to find in the flask after 19 kilojoules per mole of heat is added? Well, here our axis is actually labeled. Generally speaking, we don't label these axes in this course, but here is an example where the axis is actually labeled, and we have right here 19 kilojoules per mole. So if we go up to find our state of matter, you'll notice that we're right in the middle of turning between a liquid and a gas. Or said another way, we're right in the middle of boiling this substance. That means that some of the molecules will be liquid in that flask, and some of them will have turned into a gas. So we will find both states of matter because we're on the boiling curve.